later. So this is Angular templates, start to source. Little small disclaimer, a lot of this dives really in deep into Angular. If you're not familiar with anything, it's okay. Please feel free to ask questions. Please feel free to kind of stop the talk, address what you want to address, and we can move forward from there. Just don't feel discouraged, whatever happens. So yeah. So who am I? I'm Corbin Crutchley. I work for Hilton. I don't represent them literally at all. It makes no sense. I write React every day for my job, but yet somehow I'm here talking about Angular. I did Angular at my last job for about 2.5 years. I was kind of like our Angular expert on the team. I collect retro video games. I have everything from the Atari 2600 to the Nintendo Switch. And I love open source. I think I have like 700 contributions this year. So what are we going to be talking about?
Question. When you say Angular, you mean the 2 and beyond version?
Yes. No, AngularJS is a totally different piece that I will not touch. That's not true. It's not that I will not touch. I just have not gotten around to it. And given that it's being depreciated soon, I don't intend to loop back. So yeah, Angular 2 plus.
7, 10, whatever they're up to now.
I think 8 is released. I think 9 is either releasing soon or just released.
Thanks.
So what are we going to be talking about? We're going to address what Angular templates are, how you can utilize them, how Angular works under the hood a little bit. So not just from a code standpoint, but we're also going to touch on some of the theoretical things that Angular deals with in order to show and display and manage UI code. We're going to write some structural directives if anyone's used ng-for, ng-if. We're actually going to be looking at some of the source code implementations from Angular. We're just going to have a good time, try to figure out what all this stuff is about, including me. I wrote these slides a while ago. So let's start with a bit of background. So Angular has these concepts of something called a template. You build a template using an ng template tag, like here, lines 1 through 3. And by default, without line 4 on the screen, it will not render. So nothing from lines 1 to 3 will render unless if something explicitly tells a template to render. In this case, the ng-if tag will render this so long as bool here is false within the logic. So if boolean is false, it will display the paragraph tag false. Otherwise, it will display the paragraph tag true. Worth mentioning, the false temp here, which stands for false template, is what's called a template reference variable, and it's how we're passing the value of this template into the ng-if on line 4 here. Outside of just having ng-if to be able to kind of explicitly declare that we want a template to render, we can also utilize another template and an input called ng-template-outlet. Here, in line 1, we're doing the same thing where we're declaring a template and we are assigning it to a template reference variable called unicorns. Then later, when we're using the ng-template-outlet, we're also rendering that same reference variable to be able to showcase it on the screen. So that's the explicit render mention. We also have the ability to have something called context. Much as a function has the ability to pass in inputs to a function, we have the ability here to pass in arguments of sorts into a template. So that's the second argument, or I'm sorry, it uses ng-template-outlet context to be able to provide an object. This object has a set of key value pairs. One of those keys is implicit, and it's what's marked as kind of the default export. So, export default on ES6. And in that case, we're binding to a template input variable called message here, which we can then display. So in this case, we have the implicit key, which is hello world. We have person name, which is Corbin. We're binding person name to the template input variable, this person's name, and we're binding the default implicit value to message. So if we look at how this is rendered out, this is going to be some terrible screen crunch, but come on. But we can see the code is exactly the same. And where is my preview? I don't know where my preview went. Oh, that's why. Okay, and the preview is available to be seen here, which is hello world Corbin. A little small. So we also have the ability to gain a reference to this template from your application logic. So within your class component, you're able to use the viewChild decorator on a property name to be able to gain reference to it. In this case, we're wanting to gain access to hello message. We're then using viewChild and the name of that template reference to be able to store that reference into a logic property called hello message template. And then just to showcase that it is showing properly, we have ng-template-outlet to explicitly render that template with a different variable name from the logic rather than from the template itself. But viewChild isn't just for templates. viewChild is also able to gain reference to a component itself. So in this case, if we have a component, say my custom component, with an input that says 50, we can use viewChild on it using the same template reference variable trick. And in the ng after view init, we're able to console log the input value to that component. So just to take a tiny bit of a deeper look, what's happening is that we have an input here on this custom component, and Angular guesses the type based on where the template reference variable is. So if you look at the TypeScript definition type, we're actually gaining access to the variable type, the component class type itself, and that's why we're able to access the variable name from the component instance. We're also able to, why is that not doing the thing? Sorry. We're also able to overwrite the assume type. So let's say that we want to gain access to the underlying HTML element rather than the class component instance itself. What we're able to do is we're able to use this read prop on line 13 to tell Angular explicitly, hey, I want reference to the underlying element that this HTML component is rendering to, rather than the component instance that this element is associated with. So for example, if we have a dataset attribute, which is on line 7, called, in this case, unrelated attribute, we can console log this attribute from the native element itself rather than from the class instance. So we're overriding what assume type Angular has on that component instance.
So that means you're accessing the DOM element node?
Yes. So
not the controller.
Exactly. So I'm not accessing the class instance. I'm instance. Right. Yeah, exactly. So what's nice here is that we're able to access both the instances on the DOM and within the class itself. There's also viewChildren, which is very similar to viewChild, but is able to access more than one element. So in this case, instead of querying a template reference variable, we're now referencing the class instance name itself. And that class will go find all the instances of that component that are on the screen, and you're able to treat it almost as an array. It's an array-like. So in this case, we're able to see that once the component renders, we're able to see, hey, we have two elements on screen that match your query. Because it isn't an array and it is an array-like, we can also do some interesting things with it. In this case, we're subscribing using RxJS observables whether or not a component is changed or if this query updates in any way. In this case, on line 3 and 5, we're wrapping one of the components inside of an ng-if to conditionally render it. When the checkbox on line 2 is changed, this will render and not. And every time that this component implementation does, it will randomize an internal property called numberProp, and it will calculate the sum of all of the components together in order to showcase. So we'll look at that code really quickly. We can see that numberProp is a randomized number property that is floored every time a component is instantiated. And we just want to be able to console log the combination of every item that's on the screen. So once this renders, we can see that each of the values of these components changes, and when it does, we're able to get the sum of both of them that are on the screen. And that's because we're able to subscribe to DOM changes whenever it renders. We also have the ability to embed views directly from logic. So what we were doing previously when we were using one ng template to show another on the screen is we were actually embedding it. So when you embed a template, it creates a view. And what we're able to do is we're able to do this manually from within the template logic rather than using ng template outlet. So what we're saying here is we want to gain access to a view container reference using the template reference variable. A view container is simply a way that we can read an element and treat it as a place to be able to inject views. So when we want to render a template, we have to have a view container to inject it into. When we use ng template outlet, this is kind of magically handled for us. Angular hides a lot of the implementation, but this is how it works under the hood, where we're using viewChild to get a template reference to line 4 for the template reference variable. And then on line 23, once this component initially renders, then we're going to inject a view so it will show list item 1, list item 2 inside of the div that's on line 10 with class testing. This same view container ref is also able to pass in a context. So I know that I had touched on context a little bit earlier, and instead of ng template outlet context, we're able to pass in a second property to the create embedded view ref, method. So just so that we can get a kind of holistic perspective, we can see we're getting reference to the view container, and then we're creating embedded views with an implicit tag. That implicit tag is then bound to the default input variable I, and then we're showing I on the DOM. So if I open up the element inspector, which is far too small, we can see that the unordered list now has 2 children inside of it because we're looking for the view container and rendering it there. View containers have limitations though. Angular does a really good job at hiding away a lot of its implementation detail, but 2 of the things that Angular cannot do is within a view container it cannot move elements and it cannot change the number of elements, so it cannot render or hide an element. But that doesn't seem right? We just showcased that we can conditionally render an element, so how is that being done? And the way that that works is that under the hood, Angular is utilizing some of these APIs on the view container to be able to inject new views, remove views every time that we want to show or hide an element. So it's really kind of hiding away a lot of the issues that are inherent to the system that's been built. In this case, we have the ability to move a template. So if we have an embedded view that we've put in the wrong order, so instead of saying 1, 2, 3, 4, it will now say 3, 4, 1, 2. We're now able to move the incorrectly placed view up 1 to render properly as 1, 2, 3, 4. We can also insert templates directly. So if we know the index that we want to create, we can manually create a view instead of embedding the view, and then we can manually insert that view into the view container. So the template allows us to be able to have methods on it that will create a view that is not instantiated in the DOM but is kept in memory, and then you can tell it to insert that memory view directly into your DOM. And this is actually how create embedded view on your view container works directly within Angular. So this source code is taken from Angular 8, and all it does is it creates a template view in memory, it inserts it into the DOM, it returns a reference. We also have the ability to manage and modify templates directly from directives. So under the hood, directives are just components are just a very complex form of directives. And as a result, we're able to do a lot of the create embedded view. This is so fuzzy, I apologize. We can embed views and we can create views directly from a directive rather than from a component itself. So in this case, we have an ng template. We have the directive render the template, which is marked by the selector on line 2. We're gaining access to the content child, which is kind of like view child, but for elements that are nested inside of the selector. We're getting the template reference here. We are then getting the view container ref from the dependency injection and creating that view and injecting it directly into our code. So view containers are able to be created kind of invisibly without having to use a view child using the dependency injection system. Angular knows that you want to inject a template when you ask it for a view container, so it goes ahead and creates one under the hood. We also have the ability to get a reference to the element itself. So if we have an ng template on line 20, we're able to use that same dependency injection trick to gain access to the template that the directive rather is on, and we're able to render that directly instead of having to have a wrapper and a content child. So this is a fairly useless implementation of a selector because it doesn't do anything here. But because it is a directive, we're also able to have inputs, just like any other directive would have. So in this case, we're adding a directive for that has the same selector name, so we're able to just bind it as if it is an input on the div or the ng template. Here we're accepting a string and we're passing it as the implicit value to the context. So in this case, this would say, it would be a paragraph tag that says hi there because we're binding the context. We could also, since we're on the pattern of rendering templates and adding in context, what if we just made a totally separate context that allowed us to pass in an object for your context and the name of a template reference variable, and suddenly we're left with an API that looks rather familiar from the beginning of the talk. Think ng template outlet. In this case, we've renamed it to render the template, and it contains one input that contains the template reference and another one that contains the context, and we're able to render the name of another template with a context. And we've just recreated some Angular source code for ng template outlet. We can move one step further though. So additionally to the idea of directives, there's also something called a structural directive, which I hinted at the beginning. If you've used ngIf, ng-for, any of the built-in utilities provided by Angular, you've already used some of these before. In this case, what it does is it wraps the element that the structural directive is on inside of an ng template. So if we look at line 20, all we've done is added an asterisk to the render this, and we're using the dependency injection trick as before. So we haven't modified a lot of the code for the render this directive from some of our previous examples. The only difference is instead of having to have it be an ng template and then a paragraph tag, now we're adding an asterisk to imply to Angular, hey, please wrap this in a directive, wrap this in an ng template. And what's nice is that because all the asterisk is doing is wrapping it in an ng template under the hood, we can actually apply it the same way we did before, where we're just adding render this directive onto an ng template and just rendering that outright. So in this instance, we can do a very, very rudimentary form of the ngIf structural directive, where if on initialization the input to that directive, because again it is just a directive, is false, it will not render, but if it is, it will create a view and embed that view directly. The problem is whenever you go to update that, you're no longer initially instantiating that directive, so we'd need to do something like this, where our input is a setter, it runs an update function, and this conditionally either clears the the view container, or it will create a new reference. So in this instance, I'll add a console log here. So we can see that when I'm updating this value, this setter is ran, it runs the update, and now we're able to conditionally render an item on screen using nothing but a homebrewed version of ngIf. And again, this is a much more, okay, I now don't have internet connection. That's fine. But the concept is the same.
Engineers work around problems.
Exactly. If anyone's used ng4 for more complex instances, has anyone used something like let number of numbers semicolon first equals first? Has anyone used something like that? Or let index equal index? Anything? No? Okay. Well, microsyntax is a way that you can have very verbose directives without having to have a bunch of inputs on the item itself. So in this case, we have our input, which is bound. So we need to make the selector and the setter match the same name. And if we're able to do that, we can pass in a value directly. Excuse me. But we can also bind the context directly. So in this case, implicit becomes message. So we've just made a Pig Latin structural directive, which will make any message into Pig Latin. We're also able to pass in named context values. So if you remember towards the beginning, person name was a named export on the context. We're able to do so here as well. So original message is just bound to a new key in the context. That key is then referenced by name, and now we're able to use this. So the message, this is the string, is whatever the Pig Latin version is in Pig Latin. We also can have multiple inputs. So let's say that we wanted the ability to have an uppercase or a lowercase message of Pig Latin. We can pass in casing, which is an input for upper or lowercase. So now we could go even further. So the message blank is original message in uppercase Pig Latin. So we can really take this API and make it very, very verbose. And all that means is that we just have to preface casing with make Pig Latin casing. So it's just a little bit of naming convention. We're able to utilize this very powerful syntax. There's also the as keyword, which if anyone's dealt with asynchronicity in Angular, you've probably come across this at some point, where let this observable pipe async as whatever, and then utilizing that elsewhere. We're able to expand that here. It allows us to be able to get the value from an input. So in this case, we can have the uppercase version of the message saved just by passing in a pipe. Which, to clarify, this uppercase pipe is not something that I've done. This is built directly into Angular. It allows us to store values directly from within. And in order to make this work, all we have to do is we have to return the name of the input as the same thing. So in this case, casing uppercase, we can just return the key make Pig Latin casing, and it will allow us to be able to preserve what upper pipe uppercase is. So in this case, it would be like upper with all caps. The one thing that is quite interesting about the microsyntax is that it's very versatile. All of these are valid. Some of them have semicolons, some of them don't have semicolons, some of them are arranged in different orders. All of those are valid though. That is the actual regex that's used for testing whether a microsyntax is real. It is big, jargonous, and confusing. It's a little more structured and clear here, where the colons and semicolons are optional. In order to bind certain things, you can use specific keywords. But this is much more intended as an in-depth when getting further into microsyntax. So, let's see if we can apply everything that I've just covered here. Let's see if we can remake ng4. We've already done ngIf, let's do ng4. But some ground rules, because the ng4 API is way too versatile. There's way too much in it that I'm not going to cover right now. And I'm not going to worry about garbage collection. I'm not going to worry about updating the array, because that adds some additional fun complexity. I just want to be able to use a syntax very similar, where I want to see if an item is the first item, render each of the items in that array. So I have some code here that I've set up as just a basis. I want to be able to have a syntax very similar to this. So let me copy that, drop that in, and it's immediately going to complain about the thing that I'm going to fix. So if I add in, first let me go over what I'm doing. So I want to be able to use an async pipe on this numbers observable. This numbers observable is going to return an array, and we want to be able to render each of these items in the array as number in a list of, and the number of numbers, and then that actual number itself. And if it is the first item, we also want to add the message, it's the first number. So this, line 19, is the syntax that we're going to use to do so. So we have let number of numbers, so I need to add the of keyword. So I'll do input, uni for of, and that's going to be an array. I'm also going to double check that I am correct by implementing after view init. So if I look in my console logs, I can see that that was an array. In order to create the elements on screen, I'm going to create a constructor. I'm going to get an instance of the view container ref and the template that it's on. I'm going to this.uni for thereof. So for each of these items, I want to create a template reference and be able to create a view. So in this case, I'm going to do this.vc, create embedded view. I'm going to pass in the name of the template, and I'm also going to pass in the context, so we can see that it's now rendered the proper amount of time. And now I can pass in the number. Of course, it's going to fail on me for unrelated reasons. I'm going to edge case that for now. So now we can see that even though Now we can see that even though the full list of numbers isn't rendering, we can finally get 1, 2, 3, 4, 5, which is the expected output of this async. I want to be able to see if an item is the first item. So first is the name of the key that I need to pass. And that's easy enough. I can pass in an index key. So is I 0. So now we have that working. And finally, we can return the uni for of as this.uni for of. And now it should finally list how many numbers there are. So just within a few moments, granted I've practiced this once or twice, but just within a few moments we're able to make a fair implementation of the ng4, which allows us to be able to just take this code and just expand it into some very, very powerful tools with built-in support for observables. Yeah. So it's a very powerful tool once you understand a bit more about templates. And that's what I have for you. So I did a much more in-depth dive that covers how Angular kind of handles some of the stuff internally. Admittedly, those slides I thought were in this version of the talk and were not. But if you go to Unicorn Utterances, there's like a 55-page post about all of this stuff that explains much more. Feel free to reach out. Feel free to ask questions. Are there any questions?
So what made you deconstruct ng4 and ngf?
Sorry?
What made you deconstruct ng4 and ngf?
So there was an instance in our code for my last project that was perfect for a structural directive. It required both templates, it required the ability to conditionally render, but I also wanted to have all sorts of additional logic in there. So I wanted to go make a network request, I wanted to do XYZ, and then I wanted to render a template, and that template had to depend on a bunch of different things. That's when I finally had kind of had to learn what a structural directive is, why it is, and how to utilize it, because I was trying to make a component API system for my coworkers who were less familiar with the way that a lot of Angular worked internally. And from there, I started writing a blog post to launch my site, and I just kind of dug in deeper. And funny enough, a lot of this stuff, anything about templates, anything about structural directives, there is either extremely little, 1 or 2 sentences, or no code documentation whatsoever. This regex looks absolutely ridiculous. Can we all agree at very least that this regex is bananas and should not have been marked as documentation?
Please make it go away.
It's enough threat to the universe.
This regex, and it's not real regex by the way, but this regex, no joke, for 2 years was the only official documentation on how microsyntax worked, period. Even now, this stands as a majority of the documentation that exists within the official Angular templates. So I wasn't very happy with that. And their official line is, well, if you want to learn it, go read the source code. And no joke, I've seen that line referenced directly in documentation through messages with the maintainers. It's kind of their underlying.
But it's self-documented.
Sure, it's not. you and I both know it's not. So the reason why the blog post is 55 pages is not because, oh gee, I really like writing 55 pages. It's, oh my God, look at everything that wasn't documented. So it was my best ability to try to document everything in the most structured way that I could. I realized this talk was fairly fast-paced. I swear the blog post is better. I solemnly swear it is. There are 93 examples on that post. But I have tried my best to condense a lot of information into a somewhat palatable talk. So I apologize if it is fast.
No, it's not bad. It's complex, yeah.
Yeah. So that's kind of the reason why, is because they told me to. Don't tell me to go read source code, I will. And then I'll teach everyone else how to read it too. Haha, payback. So, but yeah.
Any more questions?
I'm wondering if I can add one more piece, if that's okay with everyone.
Go for it.
It's going to be somewhat ad hoc. And I swear I'm not doing this just to load the very pretty site.
Trying to push right part.
Okay. Is everyone familiar with the DOM tree? Yeah? Okay. So, if you're not, really quick recap. This is what I'm going to zoom in on that. This is something that we'd see in HTML code. We have a main tag, we have an unordered list, we'd have 2 list items and a paragraph as a sibling to the unordered list. The way that this is handled by your browser is something like this. We have a main tag as the top, our child are the P and the unordered list, and as a child to the unordered list, we have 2 list items. So it creates a memory tree in order to parse. So when you do something like this and look for ID B, children LI, it will go find B and it will go find the children LI to apply this CSS to, right? So the tree is really nice for being able to very quickly parse and handle things. Angular, unsurprisingly, has its own implementation. The reason why you can store a view, and these are the slides that I thought were missing and I don't know where they've gone. The reason why you can have a view without embedding it directly is because Angular keeps its own state. It keeps its own tree of these views and the elements that are on screen in order to render it. It is not, it's actually not the shadow DOM, nor is it really a virtual DOM. A lot of people think it's a virtual DOM and it's very, very similar in a lot of practices. The problem is there's no standardization on what that really means, because of course there isn't. But it is much more similar to a virtual DOM. Shadow DOM is just what this mental model allows for. So we're able to render from Angular to a shadow DOM because Angular has these concepts of an immutable DOM structure. Which is why, again, you can't create or move views without either unrendering a view or elements without changing a view in some way, because it's meant to be this immutable structure that directly correlates to the DOM. So in this case, we have templates, we have views that are referenced by templates, and we're able to put in view containers. So there's an element that is also a view container. This view container is able to have a template, which then renders a view. So Angular has its own way of having, every time you create a directive or a component, all a component is a directive plus a little bit of sugar to add in a ng template, and that's it. That's the only difference between a directive and a component in Angular, is the concept of a host view, which is just implicit magic, and Angular adds it for you. A view container that is then used to render all of the children elements, and it's why you can have a component that renders things conditionally. Gets very complicated after this chart. I actually think that's the last chart I made because it gets so like stupid ridiculous. But Angular uses these concepts of views everywhere, whether you acknowledge it or not. Every time you use a component, that's a host view. Every time you conditionally render something, or even every time you update a DOM element using your input from logic, that is a host and a view that is then just re-rendering every time. So it's how Angular is able to track what you have in logic, and it's how it knows what to go update because it already knows in memory where these items are and how to go access them. So
How is that different from React?
it's very, very similar. And this is always the frustrating part, is that if you talk to one of their devs, actually, to be fair, both dev teams are very responsive and they're both very respectful to the other teams. But if you talk to a lot of community members, they'll go, oh, well, they're not the same. And there are very, very specific implementation differences. React doesn't actually have the concept of a template at all. It just has an element. So it's much more verbose in how one-to-one it correlates to an element. Angular provides like this abstraction on top of it to provide an immutable model and blah, 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 blah. But really from a very high level 1,000-foot perspective, they're extremely similar in that they both contain some form of memory that represents the DOM and a way to render into that DOM. It's just very different how they do so under the hood.